There we go. So inequalities is what we're going to play with here. So inequalities are either something like greater than or equal to, or less than or equal to, or just not equal. Anything that's not equal that's related to two things. Mostly here, we're going to play with these four. So a few different things to do. I just want to look at, what it looks like with a variable and then on a number line. Earlier, we wrote things like x equals 2, pretty straightforward. When I write things something like x is greater than 2, right, on a number line, that's a lot of possible answers. So if this is 2 right here, we got 3 on one side and 1 on the other. And x has to be greater than 2. So like any number out in this direction is greater than 2. And I put an open circle at the 2 to indicate that's the edge of what's acceptable. Versus, what's that? That's the open circle. Yeah, the open circle is like the greater than. It means you can just go to the edge of that, but you can't use 2. Versus something like x is greater than or equal to 2 on a number line. Any number to the right is acceptable. So I shade that somehow, and then I put a closed shaded circle to indicate I can use 2 because of the equal to. So if it's a not equal to, if it's just a greater than or a less than, it's an open circle. If you have the or equal to there, then it's a closed or shaded circle. And whether it's less than or greater than, it's just you're on the right or you're on the left. But that's important. Ooh, next, compound inequalities. We started looking at a while ago, like when we were looking at when a person drives and texts, if they look down for like 2 to 6 seconds at 35 miles per hour, we figured out what the range of distances they could have covered were. Compound inequalities, finish that. So that's things like number line wise, when we say an answer is between 2 places, like maybe 2 and 6. And let's put open circles and then shade the middle. So a compound inequality is to use to describe usually something that looks like this on the number line. And the way we write that is we put our variable in the middle. Let's say it's x. And looking at this, would you agree x has to be less than 6, right? Okay, so I put less than 6. And over here, x has to be bigger than 2 because I'm to the right of the 2. And from x, that would be read x is greater than 2. So we always read these from the variable. Read from variable. So when I read this, I would say x is greater than 2. And x is less than 6. Now, you could read that 2 is less than x is less than 6, but that's not the proper way to read it. Proper way to read is from the variable. And these are called compound inequalities. Basically, you always read from the middle. Yeah, you don't read, whenever you have a compound inequality like this, you always read from the variable, from the middle. So you start with the x, and then you read this way, and then you read that way. But first, read that direction. Second, read that direction. Is the proper way to read it. But the most important thing is not reading it correctly. The most important thing is that an inequality that looks like this gives you a number line that's contained like that. That's the big idea here. All right, next idea. Interval notation. Interval notation is where I state it without using an inequality. So I would write 2, 6 to indicate 2 is the left number, 6 is the right number. Because that is a less than, I put a parenthesis. Because that's a less than, I put a parenthesis. That's called interval notation. So I have 3 ways to say the same thing. This says the same thing as this, says the same thing as that, right there. All right, so I'm going to give you another one of these. I want you to write it out in 2 different ways. So I'm going to give the number line. I want you to state the compound inequality, and then I want you to state the interval notation. And you should have questions about this. All right, so here is going to be my number line. Let's put -2 over there. And let's say this is 15 over here. I am going to shade the -2, open circle on the 15, and put everything in the middle. Oops. So what would the compound inequality look like for this? Write that down.
Oh, write it down.
Yeah, write it down. Because then we're going to try and make the interval notation to go with it too. So it should be something like x is greater than or equal to -2 and less than 15, hopefully is what you wrote down. Okay, the interval, I write a -2, 15. The less than, because it doesn't have an equal to, gets a parenthesis. Does anybody happen to know what it gets if it's an or equal to? It's a bracket. Yeah, nice. It's a square bracket if it's an or equal to. Yeah, and all 3 of these mean the same thing. 3 different ways to say the same group of numbers. The parenthesis means it's not equal to, and the square bracket means there was an or equal to in there. So another example, if we had a number line, and on the number line, let's see where we're going from, like 5 to 13, and both were shaded and everything in between, then inequality wise, that would be x is greater than or equal to 5 and x is less than or equal to 13. And because they both have an or equal to, I would do 5, 13, and both get square brackets because of the or equal to. So the square bracket goes with a shaded circle, and the parenthesis goes with an open circle. Okay, one more example, and then we're ready to start looking at these problems. New page. If I have something like, let's take, like we had before, we'll shade the 2, and then we'll go to the right forever. If that's 2, this would be x is greater than or equal to 2. For the interval notation, we always write the leftmost number first. So I would put a 2, comma, problem. There is no biggest number on the right. So what we do is we put the infinity symbol, which means go to the right forever on the number line. Now, the 2 here is shaded. So does it get a square bracket or a parenthesis? Square bracket. Now, the square bracket means you can actually use 2. Now, infinity, it ain't a number. It's a direction. You can't use infinity in equation, so you have to put a parenthesis anytime you have infinity. You can never put a square bracket because you can't get to infinity. It's not possible. It's a direction, not a number. So with that in mind, try this out. Suppose we had 5 over here, and we have an open circle on it, and then we shade everything to the left. What's the inequality that goes with that? And what's the interval notation that goes with that? So inequality right here, any number here is less than 5. So we just write x is less than 5 is the inequality. For the interval, what's the rightmost number?
sideways.
That would be the leftmost. The rightmost, right, this side here, the 5 is the boundary on that side. So it has to go on the right side of the interval. And then on the other side, it's definitely an infinity, but to indicate to go to the left, that's where negative numbers live, we'd make it a negative infinity.
If it's the left, it's negative. If it's
Yeah,
right,
it's positive infinity, yeah. And infinity isn't a number, so it has to have a parenthesis. And the 5 is not shaded, so that has to be a parenthesis too. So that'd be the interval notation for that one. Okay. So interval notation is a little weird if you've never seen it before, but it's just a way to describe a group of numbers instead of drawing it on a number line. But it's supposed to mimic the number line. Numbers have to go in numerical order, left versus right.
Interval notation is nice because we're only moving in one of two directions.
Yeah, it is. I like it too. Yeah. So again, this kind of notation here with the parentheses is called interval notation. It's just a slightly more compact way to write groups of numbers that are answers. And back to the regularly scheduled program.